Okay. Are you sure?
Yeah, just about to.
Okay.
Okay, everyone. Good afternoon, and it's a pleasure to be here. Thank you, Mike, for inviting me. It looks like we've had a lot of interesting sessions, and I see that so many of us are glued to these sessions. So today I'll be sharing with us on the topic of machine learning for mission critical applications, and um, we'll be looking at some really interesting things about how to build, really critical applications and infuse machine learning into such systems. My name is Zion Pibui, and I'm the principal data scientist at Periculum. I lead the data science team. So Periculum is a Canadian data analytics and data science company. We build the analytics and machine learning infrastructure for fintechs and for several industries serving underserved markets across Canada, Africa, and Southeast Asia. So moving on, I think I have a, sorry, just a second. Okay, so sorry about that. All right, so we're talking about machine learning for mission critical applications. And when we talk about mission critical applications, we're simply the term mission critical, we are really referring here to the kind of applications that organizations utilize by which if you stop running those applications, the missions fail. The organization literally fails at what they do. Take for example, I'm sure most of us here we use Uber or we use Bolt to book rides. So probably some of us came here in those rides. Now, um, data science and machine learning are so critical to those systems that the moment we stop or you stop running data science or machine learning algorithms in those systems, the business literally fails. They lose revenue, they lose key business, they start recording losses on key business metrics. So that tells you that these algorithms or these data science models in these systems are mission critical to the success and running of these organizations. So just a bit of background about me. I have an academic background in physics and mathematics, and of course, I've also been a major beneficiary of online courses. So ranging from Coursera to YouTube. So please leverage online courses a lot. They are going to help. So online courses have been very helpful to my 7-year long career in, working with data. So I have 7 years of experience, combined experience working with data, from data analysis to research to quantitative analysis and to data science. I also have I have several certifications in data science and machine learning, but for the topic we're looking at today, which is mostly around production machine learning, I have certifications from IBM and Google, and so some of these things that we do in the industry are very highly specialized, and we'll be looking into some of these issues. We'll be diving deep into actual applications of machine learning beyond just theory. We'll be looking at things around attacks on machine learning models. We'll be looking at things around privacy and security. We'll be looking at things around governance. How does my team, for example, how do we handle really critical issues in data or with machine learning when the machine learning models have been deployed? How do we take care of the issues that arise when the models go live, issues beyond what we could actually test when we're running experiments and when we're building those models? We're talking about some of those things. And so before I proceed, I just really want to know what the background here is like. So I just want to be sure I'm talking to an audience that really catches what I'm saying. So what I'm going to talk about today is going to be beneficial for everyone, but I want to know how many of us here are beginners or you are new to machine learning. And I just see your hands. Okay, great. So how many of us have some form of experience? You've worked with machine learning models, you've built some models, you have experience building models, maybe, or even if it's up to a year, just can I see your hands? So more than a year, you've built models, you've worked with different types of algorithms, whether it's classification or regression. So, okay, but if I talk about a classifier or a regression model, you know what that is, right? Right? Okay, so that's the important thing is just for us to really understand what machine learning is, and then we are going to look at some of the things that go beyond model building. And often we think that it's the complicated part of machine learning is building models, but by the time we are done building the models, we now have the giant, the monster that starts to really deal with us, which is deploying those models in production. After deploying the models, we are faced with another giant, which is monitoring those models in production. Okay, let's assume we are taking care of monitoring. So we have set up observability, we have platformized the entire thing, we automate the entire infrastructure. Everything is working fine on the cloud. What happens next? Thousands, probably millions of users begin to use these systems, machine learning models in production. And maybe you begin to see things like data poisoning. External people attack the models. You have issues like adversarial attacks and all that. And when all these attacks happen, how do we mitigate the impact, negative impact that all these various issues have on our models? Okay, so we'll look at four key areas. So I'll be talking about 4 key areas. Just briefly share with us on how companies use machine learning, and we would also talk about machine learning factors of scale. And then we'll talk about AI incidents. We'll look at classic model failures in the industry and the lessons that we get from that. And then we'll wrap up with model governance. So I want to, as much as possible, be able to do this in 30 minutes. So help me God. All right, moving on. So the first part, how companies use machine learning. Now in the industry, machine learning is used at various scales, right? We have small organizations that use machine learning at a very small scale. They just work with maybe megabytes to gigabytes of data, and they really what they're doing is, for small businesses, maybe you're building for internal use cases, and for pet projects, like maybe you want to build your own side machine learning project. You're just going to be working with minimal data, and your model is not going to be served to thousands or millions of users. Maybe you just want to show like dozens of persons, your friends or your peers, or even in interviews, you want to showcase your project. So this is small scale. Then we have reasonable scale, machine learning at reasonable scale, where we begin to talk about gigabytes, terabytes of data. Then we have machine learning at large scale, where we begin to talk about Facebook scale data, Uber scale data, Netflix scale data. You begin to talk about petabytes of data. A petabyte of data is 1,000 terabytes of data, or 1 million gigabytes of data, or 1 billion megabytes of data. That's how big it is. Now, an organization like Facebook, they generate about 4 petabytes of data. That's 4 billion megabytes of data in 1 hour, right? Just in 1 hour. That's the amount of data that is generated. Now, as this scale of data scales, as this utility of data scales, so does the investment in the infrastructure for housing and maintaining the models on top of that data scale also. So it scales in proportion. So which means for small scale, you can just use very little Amazon credits to deploy your models in the cloud, right? By the time you get to reasonable scale, we're going to talk about, okay, now we have to now set up an infrastructure. We have to start thinking about costs and all those things. We have to make sure that Amazon does not wreck our budget and send us back to the village. So then when you begin to talk about large scale, right, these guys are operating with data centers across the world, and the investment in the data infrastructure and the machine learning infrastructure is in billions. They can throw that money into those projects because they have what it takes to do that. I don't know if we're following. Are you guys with me? All right, moving on. So for small scales, simple use cases like I mentioned earlier, you have, for businesses, small businesses, you have internal use cases like ad hoc analytics. So let's say you are the only data scientist in your organization, and your CEO probably, or you'll be MD or head of operations, just says, we want to know, what customer performance is like. I want to know what churn rate is like. Very simple machine learning use cases, the ones that anybody that is entering into data science generally builds, like customer segmentation and things like that, right? So when we begin to talk about these various use cases, then these are just simple internal use cases. Then when we get to ad hoc, when we talk about other applications, not just use cases, we also deal with things like web applications or general, maybe Android applications or iOS applications, the things that you can build using OS specific machine learning frameworks like like TensorFlow or like Core ML for Apple, right? So these are the kind of tools that we use in these cases. Now, when we get to the to medium scale or reasonable scale, right? This is the level where you begin to deal with gigabytes to terabytes of data. You have dynamic pricing model, which is a model that operates in Uber or Bolt when you want to order a ride, and it dynamically adjusts prices. The model that does that is an optimization model that optimizes prices in such a way that it is fair for you as a rider, and it's also fair for the business. You have recommendation systems. Now, these are the kind of various systems that we can run at a reasonable scale, where you expect to have tens of thousands to hundreds of thousands to even millions of users on the platform. And for this kind of systems, we now begin to think about, okay, let's create an infrastructure to house our data, to house our models, and to also automate the entire pipeline, that we are working with. And in such organizations, you only talk about dozens to maybe 100 or 100 plus team members. You're not really going to be talking about thousands of team members. By the time you get to FANG scale, the big tech, the big guys, Facebook, Amazon, Apple, Netflix, and Google, you begin to talk about petabytes of data generated. You begin to talk about large-scale investment. These guys are building applications such as ChatGPT. How many of us are aware of ChatGPT that has taken the internet by storm? They are building. These are large language models that not just millions of people are using, but potentially billions of people are using those models. And what that means is that you have to be able to create an infrastructure that can handle or that can scale to the size. You have to be able to invest, and because these big tech guys have the money, they can throw the money into, they can throw billions of dollars investing in infrastructure. Okay, so I think. if I'm good to go.
Let me check this out. Hello? Hello? Can you hear me?
All right, I will be to go. All right, we're back. All right, so I was talking about the various scale of applications and how it is done in different organizations at different scale. So at the very large scale, you have these guys that can throw in billions of dollars, right? So, but for the vast majority of organizations, they operate either from the reasonable scale or downwards. And even reasonable scale is actually really big when you talk about gigabytes to terabytes of data, right? I don't know how many of us have tried to load 1 gigabyte or 5 gigabytes or 10 gigabytes into Excel. Have you tried it before? What did it feel like when you did that? You know, it will feel slow. Excel can even truncate the records, right? So you just literally break down the application. So what you do in such a case is to now move it to more suitable systems for, you know, for capturing and analyzing such data. Now, I want us to, when we begin to operate from a reasonable scale and beyond, in fact, when we start using machine learning for commercial applications, we now need to understand that to get the most value out of machine learning, we need to build and deploy these models as products, specifically as data products. Now, a data product is not just any kind of product. It's not just a type of software product. It's not the product that just merely delivers data or merely generates data and delivers data. A data product is a product that delivers data as part of its major value proposition. What that means is that we build this data product. It has a target audience, right? And the major value proposition of that product now is that it is delivering data, it's delivering knowledge to the target audience. All right. Now, these applications, these data products can be internal or external. So if they are external data products, they are basically the data products that are customer facing, that are serving customers, right? So think about what is happening on your search engine, how models are working on your search engine to give you the most relevant search results. Those are called relevance algorithms, right? Now, these data products now, they are customer facing, so they are external data products. Then we also have internal data products, and then internal data products can be of two types. There are those internal data products that are serving internal users or internal business stakeholders. You know, think about things like employee assessment. Think about things like, you know, operational analytics. We are trying to understand what is going on within the organization. So these data products are serving decision makers, stakeholders within the business. Then we have another type of internal data products that are actually customer facing, but they are not external data products. What I mean by that, I'll give you an example. So recommendation systems, for example, are internal data products, right? So, but you might want to argue recommendation systems are customer facing. We build recommendation systems so that they deliver recommendations to users, but they're internal because the end goal of recommendation systems is not to give users knowledge as a final output. It is to give them knowledge as a means to an end to drive them to take a certain action. So it is circling back to the internal users who need those actual outcomes that the recommendations drive. So we make recommendations to you. The recommendations are smart enough. They drive you to take an action, right? When you take an action, you actually buy or you click or you perform something that we can track internally, right? So they are actually internal products, but they are customer-facing internal products that eventually circle back to creating value. So these are what data products are. And when we begin to look at models in the light of data products, our thinking changes. You know, when you start out in machine learning and you start building models, it's all about the accuracy. It's all about the performance. It's all about, 99% accuracy. Our models are predicting well and all that. But by the time you come to the industry, now the business doesn't care about your accuracy scores. They care about money. How do you convert that data to dollars? We are not just interested in, in the accuracy scores. We want to see numbers. We want to see money. All right. So when you build such applications or such data applications or machine learning models, you now need to see how you now need to look at them from the lens of data products, from the lens of products, and that helps you understand that this is something that's really delivering value. So you now need to understand how to connect those models to value and how to create, various other systems around those models to ensure that they are really solving the business problem and increasing value. I'll walk through a use case in my team, a data product use case in my team. So in Africa, of course, there's a very huge credit gap, $350 billion plus credit gap. What that means is that if you think that a lot of people are getting loans today, you're wrong. We are not even anywhere close to the potential that we can have in the credit industry. What that means is that we still need more and more people to have access to better loans, right? So, I mean, everyone here, for example, is supposed to be able to get as much as maybe 500K to even 1 million loan at a go, right? But that doesn't happen. You sign up on some of these apps, and then maybe the best that they give you, that they offer you, is 5,000 naira. All right. I don't know if I said dollars earlier. I'm talking about naira now. Okay. So now we have, a very huge credit gap, and financial institutions have come into Africa, even the indigenous ones, trying to solve some of these bottlenecks, trying to create innovations, and they raise a lot of PR about what they offer and all of those things. But the major frustration that actually hits them and prevents them from scaling the efforts to bridge this gap of credit in Africa, a major hindrance is high rates of non-performing loans, which I have abbreviated there as NPL, non-performing loans, which means people default a lot, right? So if people default a lot, does it mean that there's no potential for the credit industry in Africa or in Nigeria? No, it simply means that we're not targeting the right people, or we don't even know how to decide who is the best person to get a loan and who is the best person to that would actually pay back those loans. So the struggle that they have, that these institutions have, is not really that they don't have enough financial information, right? It's not that they don't have access to this financial information. I mean, it's not because there's unavailable financial data or financial information to be able to create the right decisions, but because they don't access the best ones, right, one, and then they don't have the infrastructure, the capabilities to actually analyze, a very vast array of data and be able to create the necessary insights, right? So how do we, approach this kind of problem? Now, machine learning is mission critical to us, because if we stop building machine learning models, or we stop productionizing these models, or serving the industry with these models, right, we cease to be a business, because that's essentially what we are doing. Now we build the analytics and machine learning infrastructure that the fintechs use. So every time you open Fairmoney, or you open OPay, right, at the back end, the models that are really powering those systems are our models and algorithms. All right. So this is mission critical to us, and what we really do as an organization is to solve the problems that these financial institutions have, which is lack of financial information, rich financial information, and then ability to analyze, to create proper credit decisioning. So we offer high quality financial information to these companies, and then we also offer speed and accuracy of credit risk assessment. And that's pretty much what we exist to do. And there are three core data products that we actually have, that we build and deliver. We have the Unified Data SDK, we have Curriculum Insights, and we have Lumen. So let's say, for example, you are a fintech organization, and you want to be able to improve your non-performing loans, which means you want people to pay back. So you want to be able to target the right customers and know exactly what persons are going to really pay back on those loans. All right. So when you come to our platform, for example, and give you Unified Data SDK, right? What Unified Data SDK does is that it gives you a very broad access to literally every financial data of the user, as long as the user offers permission for the app to take those information, right? So it's not just looking at bank statements. It looks at bank statements. It looks at telco data. It looks at switching data. It looks at SMS data and various other things, right? And with this now, it can provide a more holistic overview of a customer's credit worthiness. So is this customer really worthy of this loan? Is the person what's the probability that this person will pay back? and what is the risk at default if the person defaults. So with that now, an organization can adjust what it can offer based on its risk appetite and based on the insights. So now unified data is the foundation for the products that we build. Then we have insights, the insights API that is built on top of that, on top of unified data SDK. And what this one does is that it just leverages machine learning. And then when we look at your data now, right, unlike the existing methodologies, the legacy methods you are using to analyze or to determine who gets the credit, right? We expose over 80 variables in that data. So we have 80 variables across different areas, across your income, across cash flow, across transaction patterns. The only way we will not have access, or the only way that using our API, a company will not have access to these variables across these 5 areas is if you as a user do not give them permission to access those things. But as long as it is permissioned, we are able to now deliver inference, machine learning inference, or machine learning predictions, or machine learning decisioning capabilities to those to those organizations. And then they now know, they see it on a live administrative dashboard. Okay, these are the users that are actually worthy of of the credit. And so we serve different industries across several continents, across Canada, across Africa, across Southeast Asia, and across South America as well. Industries including digital lending, embassies, investment management, and so on and so forth. All right. Now, this is not just about pitching our product. It's just about really helping you to understand the capabilities, and also see that as an organization, if we stop utilizing these systems, or if we don't build the necessary systems that make these models work effectively, right, the organization is going to fail, because we'll start delivering bad insights to the other businesses that are using our APIs. And when that happens, right, we're going to experience a lot of churn. We're going to experience backdrops in revenue and all of that. So machine learning is mission critical for us. All right. Now, machine learning factors of scale. So what are the underlying things? The underlying things, or the underlying factors that makes machine learning scale up to to really large use cases. So the first factor of scale is that we need to now take algorithms. We need to go from algorithms to products. So we need to take machine learning from just the algorithms, or from just the artifacts, to actual products. So what that means is that you would likely have a data product manager. For example, my team, we have a data product manager who understands data and who is able to look at everything from the lens of, from a product perspective, and is able to connect the dots between the technicalities of our workflows and workloads and the business outcomes, the outcomes we're trying to deliver. We want to increase revenue. We want to increase our customer base. We want to be able to eventually target millions and millions, and hopefully billions of users, coming through these various organizations that are leveraging our platform. So to do that now, I identified like 4 key areas, or four P's that you need to really understand to make models useful and valuable, and to take them to a commercial level where you can actually commercialize those models. You plan, which means you design the roadmap for what you want your model to achieve beyond just accuracy and performance scores. We now begin to work on the process. So the process now is a learning algorithm. So the learning algorithm is the process of actually learning from the data and capturing the relationships and patterns in that data. Then we now go from from process to prototype. So basically, the outcome of a learning algorithm is a model. All right. So I always like to emphasize that machine learning algorithms are not models. So a learning algorithm is not a model. A model is the outcome of a learning algorithm. So think about the algorithm as a process and a model as a product, all right? But in this case, I'll call it a prototype. So which means the first thing that you get after you have run experiments, you build your machine learning models, that classifier or that regression model, right, that you now have that can start making predictions. That is your prototype or your model artifact. But now that we want to start thinking commercial, we want to now take these things to the next level. Now we want to deploy it. So this is where we now go from prototype to product, where we serve these models to actual users, to people who are going to utilize these models. Now, the next factor of scale is automation, where we now talk about, okay, how do we, as much as possible, remove humans from repetitive aspects of the workflow. All right. So there are certain things that we are able to automate in the system. We can automate model training. You spend a lot of time when you start working on your proof of concept, which means the first time you want to build your model, the prototype, right? You spend a lot of time researching, experimenting, and all of that. But by the time you have everything figured out and you've actually built your first model, maybe you've even deployed the models, the next thing you want to do then is to be able to automate the procedure. You want to be able to, to automatically train models without an individual having to be involved in the steps. All right. So we automate model training, we automate continuous integration and continuous deployment. In fact, we automate continuous training, continuous integration, continuous deployment. We automate monitoring of these models in production. So let's say we have deployed the models now. How do we track that the model is still making sense? There's such a thing as model decay. And if we are not careful, we think that the model is serving the correct insights or correct predictions, whereas it's already bad. The model has gone bad in production, right? Which means now that the model is live and is serving hundreds to thousands to millions of customers, right? It could get to a point where suddenly it's just not delivering adequate or reasonable insights anymore. Performance is dropping, accuracy is dropping. So we monitor all these things. We even monitor whenever we want to build multiple models. We monitor the experimentation process and monitor. We get logs, right? We get the reports of how these things are working when we are running them automatically. Then the next factor of scale is instrumentation and monitoring, where you now talk about, okay, we want to instrument everything that we're doing. So we set up instrumentation to log or to collect data about the ML system. So everything that the ML system is doing, right? The entire life cycle of the machine learning system, we capture all these information, right? When the model is being trained, we capture all the training logs, accuracy scores, various issues that might occur, right? Experimentation to capture all those information, including dashboards and visualization of experimental results, right? So this is what you do. This is what instrumentation really is all about, to be able to capture all the little detail about the procedures in the life cycle of the model. The monitoring involves, we continuously assess or evaluate the performance of the ML system in production. So we monitor things like data quality issues. Is the data bad, right? Because if you serve bad data to a model that was trained on a different data, it will give you very bad results because it was not trained on this data. So when data begins to change, we want to be able to track the changes so that we can easily correct those things, right? So if there's data drift in the business, if the data starts drifting, let's say someone somewhere, just maybe at the production level, the engineers working at the software level, maybe they just suddenly changed variables, right? Or they changed some things in the database or in the warehouse. Now the data that is coming to the machine learning system is different from what it was trained on. So now it is serving wrong inference. So we have to monitor for these things in order to ensure that we avoid model failures. Because again, like I said, in my organization, for example, if these models begin to fail in production, it is bad for the business. We begin to record losses. Customers will begin to get frustrated at what our APIs are doing. So it is mission critical for us to monitor these various life cycle of the model. Then the fourth aspect is operationalization, where we operationalize the machine learning system, which means all the three earlier factors I've mentioned, right? Automation, monitoring, all these various factors now, we operationalize them, which means we ensure that we have the necessary infrastructure for all these things to run on their own in the cloud. Of course, we don't leave it autonomously to run. We have to still, manage the entire process. But then when we operate at a reasonable scale, for example, in an organization where we are operating at a reasonable scale, it's not just we be launching one model into production. We have several models running in production. All right. So we need an infrastructure that can actually house these models and house the entire processes. All right. For automating various aspects of the life cycle of the models in production. Now, there's a keyword we generally use in machine learning that deals with model operationalization. It's called MLOps. I don't know if some of us have heard of MLOps. It's a very hot topic in machine learning right now. So it's MLOps, which stands for machine learning operations, or in full, machine learning operationalization. So it just really deals with how we operationalize machine learning models by creating an infrastructure for the entire life cycle. So MLOps has a lineage or takes lineage from DevOps, all right? So maybe, there was a time when, even up to now, DevOps engineers are still, hot guys in the industry. They are highly paid. They are probably the most paid tech guys in the industry right now. So those of you that want to start earning Amroba salary now can just probably start thinking about DevOps engineering, right? But then machine learning ops or ML ops draws from DevOps. But the difference between MLOps and DevOps is that we are not just trying to automate code or create infrastructure for code or software. It's not just code. It is code, it is models, and it is data. Three things, and they're very different things, right? So it makes the entire thing radically different from DevOps. And now we have to add other things that we're trying to automate. We want to automate data, gigabytes of data, terabytes of data, for example. How do you automate the continuous inflow of this data? So you now know that you have to set up a suitable, scalable infrastructure for these systems, right? We have to automate the modeling stages. So from model development to experimentation to testing to evaluation to deployment and to monitoring, want to automate all these things. So we create an infrastructure for that. So a typical MLOps infrastructure at a reasonable scale will usually include storage and compute. So on AWS, for example, you have AWS S3 that will store your data, all right? And then for compute, you have your EC2 instance, right? Then you have resource management. So anything that's to do with orchestration of the workflows. When we orchestrate workflows, it's just basically a way of saying, I don't want to be involved in, every morning I'll come, resume, and I'm trying to now click this, click that to run a life cycle. We just automate it on the cloud. So automatically, maybe a Kubernetes cluster is being, is launched every morning to set up the orchestration of this. So the workflows just run on their own. It's automated, all right? Then we have development environment as another component of the infrastructure. This development environment is basically all things that have to do with the training, the experimentation. So these are key independent environments that must be separated, right? So we separate them, but they are all within the infrastructure. Then we have the model platform. The model platform includes when the model has been created now, we now have things around the model store, the feature store, and various things about the model artifacts. Now, on the diagram to the right here, this diagram to the right here is a machine learning or the MLOps hierarchy of needs. All right, the MLOps hierarchy of needs. When we talk about the hierarchy of needs, especially from a data perspective, basically it's a way of saying that we are trying to tell you, we're trying to create a sort of hierarchy of what are the most important things in that space, but how those most important things build upon earlier, smaller pieces at the bottom. So sometimes people want to jump to automating the machine learning infrastructure where they've not even taken care of DevOps, which means the software infrastructure, the architecture around the software and the applications that you're actually deploying to. You're not taking care of those things and you want to automate the machine learning lifecycle. It doesn't work. So you start from the DevOps level, which deals with the actual software infrastructure. Remember, DevOps deals mostly with automating code software, right? Then when you are done with that level, we now want to go to the layer of automating the data. So we now talk about data automation, all right? Then when we have handled and we've been able to take care of data automation, then we now go to platform automation, where we automate the actual model platform where the models will sit on. So everything, including the the uh, um, the infrastructure, the tooling, and all those things. We automate all those things, including orchestration and all that. Then after, only when we have set up all these various layers, are we now ready to automate the actual models and including their life cycle post-production, which means after we've deployed them to the real world for everybody to use, right? So this is what we really refer to as the machine learning ops hierarchy of needs. And it's very important for mission critical systems because we want to ensure that nothing breaks. So we leave no stone untouched. So the rigor of machine learning utility in high mission tasks, right, is beyond just trying to train algorithms or trying to beat performance benchmarks. It's beyond that. We begin to consider things that are necessary or critical for us to achieve value from those models. And most times, those critical things are usually outside the training algorithms that we're trying to actually run, right? All right. So all right, so I think we are now really done. So AI incidents and classic model failures. If you leave me here, I can talk for another 1 hour. All right, so now we've looked at a couple of things. We've looked at how companies use machine learning, right? We've talked about we've talked about machine learning factors of scale, so the things that you need. to scale models, right? Then this next layer is AI incidents. Now, even the biggest organizations experience these issues where they have the best engineers, the best professionals you can ever think of that can build their systems. Or sometimes I will not necessarily say they have the best engineers, but I'll say they have the best teams because usually they have really large teams. So eventually everybody will become much better because you have a very large and supportive team. So it doesn't mean the best people in the world are in Google. So don't think that you cannot be better than a Google engineer. But the point I'm trying to make here is that these guys have very large teams, but even with the size of their expertise, with the size of the teams that make up their expertise, and with the vast amounts of dollars that they throw at every problem, right? They still experience model failures. We're going to look at some of those examples. We have three key types of model incidents. So AI incidents are simply, times or situations or scenarios or cases when models abruptly fail, where they create serious problems. You see, it's one thing for models to fail. It's another thing for them to fail terribly in such a way that they create harm, not just to the business, but to the users that are using those things. It could be things like discrimination, a very, very big topic, right? Racial discrimination, gender discrimination, and things like that. Things that could actually bring about legal issues for these companies. So we have abuse, and abuse could be things around cybercrime, ethnic profiling, and drone attacks. And then we have attacks. So there's a very blurry line between abuse and attacks. An attack can be an abuse, and abuse can be an attack, right? So an abuse is just when pretty much bad data or bad information is introduced to the model. So maybe something like data poisoning, or maybe information that should not be served. Let's say you open ChatGPT now, right? So if ChatGPT is not careful, like if the creators of ChatGPT are not careful, if they don't create guardrails around how the system takes in what you're actually feeding it and goes back to train it, if they just make the whole thing flow such that it takes in new data and then it trains on it, it will create problems because people will bring so many terrible bad things. I've seen a lot of bad examples of how ChatGPT is being used, right? And if guardrails are not created, the system would automatically learn from the bad data and eventually start spitting out that bad data. And that will now create problems back for the organization, all right? So these are different types of abuses and attacks. Then we have failures, actual failures, like data privacy violations, performance lapses, discrimination, algorithmic discrimination and biases, different types of biases in algorithms and models. Now, let's take some classic incidents. I'll just share with us, these top guys that, yes, just pretty much 3 to 5 minutes now we're done. So I'll talk about these 5 big players, right? I'm sure these are very familiar names. How many of us know Zillow here? Very popular American real estate company, the biggest really in the industry. You have Google, you have Microsoft, you have Tesla, you have Uber. Now, despite how successful these guys have been over the years and how much they dominate the market, none of them have gone without their actual incidents and failures. So Zillow had a very critical problem, which I would always bring up in any case study, any machine learning talk. I would always bring up Zillow because Zillow is a masterclass in AI failures, right? What Zillow did during COVID, Zillow started to bet on. So basically, it's a real estate company, and they have models that make predictions of, okay, this is what this house price will look like very soon, right? So they can predict what house pricing will look like in certain areas. Now, the real estate market began to skyrocket, right? And so what Zillow decision makers do is that they hire domain experts to actually vet the model predictions against actual reality. So people who know a lot about house pricing, real estate agents, for example, right? When the model serves a prediction, the domain experts will vet the models and say, okay, that's a prediction makes sense. $100,000. That's what it will be. Very likely, give or take maybe $10,000 plus or minus, right? So they vet it. Now, because this real estate market began to skyrocket so much, Zillow became greedy. Their decision makers became greedy. They wanted to, how do I put this now? As much as possible, it's like they wanted to just be big movers and gain so much from the market movement. And so they left no chance. So when models began to make estimations and predictions, at some point, they had to now sack all the domain experts because it's like, in tech, there's this language we use. We usually say, fail quickly, move faster. Why? Because we want to, it's like just try things and fail quickly. So they were using this notion of fail quickly without realizing that the scale at which you're operating and the number of customers and users base that they actually have is very risky at that level to be able to make risky decisions like that. So they began to take the estimations of this model rather than just trying to predict. Now they actually started buying the houses themselves so that they could flip it back and gain profit from it. Do you get it? So COVID period 2020 it was working. 2021 when market crashed, all the models failed in production. All the models. Now this is not just a very small problem. We're talking about $20 billion plus in losses for the business. This model was mission critical, but Zillow refused to invest in the research that that really proves out the value of the models. They had been doing it earlier. So the problem is not that they didn't have a good team. They have some of the best data scientists in the world, right? And the problem is not that data scientists did not do what they needed to do, but because they didn't get stakeholders stakeholders wanted to run ahead on themselves, and were even the ones pressurizing the data teams and their machine learning teams to give us predictions, let us go and buy these houses, and they failed, and they failed. They've learned from it, but the industry now has it as a master class, which I can be talking about now in classes like this. And these are very important issues. Google, of course, Google works on a lot of AI innovations. So they trained a particular image search algorithm that when you upload an image, it searches and gives you results, right? So, but then there was a lot of racial bias in the models because the models were not built on balanced data that is balanced across races, right? So it is bound to discriminate against blacks, against people who are not white, all right? Google had issues. Microsoft had the issue with Techart, but Microsoft has been for years pursuing large language models. They've been trying for so long to dominate the market of natural language models that can interact with humans naturally over different computer interfaces, including social media. So what they did with the Techart bot was they launched this model into they tried to deploy it to it was a kind of bot built around Twitter, and basically we wanted to have natural language communication with Twitter users, right? But the problem with the chatbot, the tricky part about this chatbot was that they created there was a loophole in what they created, right? Where the system receives feedback from users. So anything you comment on or anything you talk about, if for example the system says something and you correct it, it doesn't check whether what you are saying is correct or not. It would actually take in that data, suck it in, and actually train on it. So it was continuously training on this kind of data. And trust me, different types of people, including neo-Nazis and people of different sort of mental orientation, they will come and introduce several kinds of information into these models. Now, this is an example. This is what we call in the industry, we call it an adversarial attack, right? From the word adversary, which means enemy. So an enemy attack, an adversarial attack. So they introduced some of these things. Before you know it, the system began to discriminate. It began to spit a lot of nonsense. It began to even bring out a lot of pornographic content and things related to very immoral things, right? And it was at that point that Microsoft had to now withdraw the system because it had already created a lot of problems. All right. So this is Microsoft and see the kind of problems that they have. So it is very important for us to have all these various governance. What we need to solve these problems is to have governance around this. All right. So we have model governance is just pretty much creating the system of ensuring that the models that we're building are transparent, they follow ethical rules, right? Ensuring that we do not create unnecessary risks to users and ensuring that we do not harm the business. So we have the legal aspects where we want to make sure that we follow every legal approach. Otherwise, you do something now, anybody can just sue an organization and say you didn't follow the legal frameworks or legal standards for ensuring our safety, or why didn't you anticipate a particular outcome that the model is producing for us? And they can take you to court. There are a lot of these big tech guys have experienced these, various issues. We have the cultural and organizational aspects where people have to be accountable. These days now we are seeing a lot of data leaders in the C-suite, where you have even roles like chief model risk officer. So model risk is actually a thing. And so we have model risk management, managing model risks and things like that. And so we have all these various guardrails to ensure that we can properly govern our mission critical systems to ensure that the model to ensure that we can mitigate as much as possible model failures and the various risks associated with these failures and incidents and how they can impact us as a business and impact end users, right? So when you have all these guardrails in place, it's something that you're able to at this point really talk about a secure machine learning system or secure machine learning systems, right? And I feel when you begin to operate from a reasonable scale, even to a large scale, these are things that are very important, and these are things that ensure the success of machine learning operations. Thank you very much. So, I don't know if
questions.
yeah.
When I come to that, to blockchain world and all that. So, late last year, some mango market on Solana has like a social attack.
Okay.
A social cyber attack that doesn't require the man just look at the infrastructure of the market, of the smart contract and all that, and takes advantage.
Okay.
Other attack also happened like that. Recently, CZ was replying to one of the Bitcoin major that said this in attackers servers are taking the majority of Bitcoin that mine. So looking at all these attacks, how can you build a model that will work in a way that it's not focused on enterprise, it's focused on the consumers, because in the crypto world there are few companies we now have a lot of consumers who know what we use DJs, we call them DJs. Okay. We just come in and make their own money and live. So how can you build a model that will help them secure their wallet, their NFT, and be able to know we also have different attacks. Some attacks are actually used with code, some are not just code, they are just using social attacks that they send you something, you need to reply, and taking over your things and another. How can you build a model that will function in that aspect?
Okay, so that's a very good one, and it's actually very related to the issue of adversarial attacks that I was talking about in the presentation. So for such systems, right, it's just pretty much a matter of actually learning from attack data. So it's a actually big use case, and you have to start from really annotating data about attacks. So you start gathering data about these various attacks, then we begin to annotate this data. So basically, you want to build a model that can learn from such data and be able to respond. Some of those models will be natural language models, which means they will be deployed as bots that can monitor conversations or monitor, social transactions or things like that, and can be able to in real time, flag any suspicious activity or content or things like that, right? So you just really need to. I don't know if there's a use case that does this, right? But I feel from what you talked about already means there should be systems, actual machine learning systems that do this, that solve this problem or tackle this issue, right? So those systems will be built on such data, and then they will be able to now real time just create inference around those things and warn you as a user. So it's a very important use case definitely. So for most social interactions, for example, I think the approach would just be to build large language models, or maybe existing large language models can be deployed in such use cases. So what you really need now in the blockchain industry is to have more machine learning practitioners or data practitioners in the industry. I know that the blockchain industry really took off from maybe 2020. Of course, that's been there, but when it comes to democratization to average users everywhere, it's from COVID period, right? So to protect people now, we need more data folks now within the industry. We need more organizations that are focused around data to solve these problems and create models around these, what you've just talked about. So it's a very interesting use case. Yeah.
Thank you very much. So, please, we have 2 more speakers. So we will give you his email and his LinkedIn and his phone number and his Skype.
Yeah. You can reach me on LinkedIn.
Reach him and then ask for the question. So let's have thank you very much, Mr. Zion. This was a very lovely lecture. Oh, this is a lecture.